Hi Robotics, this is Lathe 101 for the DC electric motor. So the lathe is an incredible machine. It's one of the only machines that can almost build itself. It works off of centers of cylindrical products and it turns the material, and the tools do the work, and the tools are stationary, which usually we are used to a drill press turning a drill, and we fasten our material in a stationary position. So this only works typically with round materials or cylindrical objects. What we're going after, if you want to come in close now, is we're going to drill a hole in the center of this dowel so that our armature axle shaft can go on here. And we're undersizing this hole by 1/64 of an inch. So the shaft diameter is 3/16 of an inch. This is 11/64, okay? Or we were saying 12/64 of an inch. We're going to undersize the hole by 11/64. But how do we get a hole directly in the center of this dowel? Process goes like this. First of all, safety glasses are a must. Okay, so safety first on that front. This is a 3-jaw chuck, so if you take 3 of your fingers and go like this, it works the same as this 3-jaw or Jacob's chuck. The jaws come together and clamp around this. The unique thing about this particular head is that it only has one driver hole in order to close all 3 jaws. So this is the chuck key. We insert the chuck key here, and as we turn this, we can see the jaws coming together and moving apart. So we're going to fasten our material in here. If you come in a little closer, when we put our material in, we kind of want to shake and move it as we close the jaws and rotate a little bit, and we can have some material sticking out. We want most of it captured by the jaws. We don't need to crush it, it's wood. So how tight? Watch my hand. About that tight right there, okay? It's not going to move, it's already compressing really well. We take the chuck key out of the chuck. Cardinal rule, we never leave the chuck key in the chuck. This would be disaster if this turned on, okay? So we pull the chuck key out of the chuck, set it up on the headstock here. It's a safe spot, it's what it's for. And then another rule is we spin the head over by hand, or the chuck over by hand. Nothing's running into the chuck. This is a cross-feed table, so normally you would run tooling in here. Sometimes this can be really close, and you always want to check for clearance to make sure it's not running into anything. In our application, we're actually going to move the bed of the cross-feed, come over here. We're going to move the bed of the table just out of the way and back so we don't have to worry about this. And we're going to be using the tailstock. The tailstock works like this. There's a number of things going on here. We have a 3-jaw chuck that's inserted in here with a tapered fit, or a tapered collet. This is just like a friction fit, and I'm going to run this all the way back, and you'll see this pop out of here. It gets to a certain point and it'll actually push itself out. This is called a Morse taper, so it's just a slight reduction in diameter down the shaft of this, and this basically got popped or punched out, so it needs to be out further. Then when we put this in here, we'll rotate it until it goes in. This slot actually lines up flat like this, then you have to slam it in place. Now normally when you come to this machine, if it's like this, it's good to go. This can't twist or rotate because it's friction fit in here. Sometimes people will wheel this all the way out and they'll end up popping this loose, and then when they go forward, this thing is hanging here loose. Dangerous, okay? So you want to make sure that there's enough quill that's fed out of this, and that you get this lined up again and slam it in place. If you're not sure, ask me, the instructor, okay? From that point, this is the brake for the tailstock, so right now I can't slide the tailstock. If I take the brake off, I can slide the tailstock forward and get it close enough to get ready to do a drilling application. Then I can put the brake on. There may be one other brake, and that's back here. If you come back here, this is the quill brake, and this quill brake can be put on so that it's really hard to turn this. So we want to make sure that this is loose and that this turns freely, okay? So at this point, we're ready to do our drilling application. One of the other mistakes we can make is running the material the wrong direction. So the flutes of the bit, if you can come in here really close, you can see there's a flute of the bit right there. That is going to want to cut. The bit should be turning clockwise in order to cut. So the material has to be turning counterclockwise or towards us in order to cut. So we have 2 directions we can go. Forward right now is the correct direction for the head. If we let this slow down, we can also reverse this, and that would be running in the wrong direction to cut with the drill. So we want to make sure that we're running the material counterclockwise so that the bit can spin in clockwise and do the cutting. So we'll run this in the forward position, and it's as easy as running the tailstock in, contacting the material, the bit will center itself, and then you feed this all the way through. And if you bring the video camera in, you can actually see the tip of the bit through the back side.
Maybe I can see it go right there.
So we know we fed through all the way. Feed this out. Shut the machine off. Take the brake off, and you can slide this back a little bit if you want to have some breathing room. How much quill can you have out of here? Here's something else that can happen. People will feed out a whole bunch of quill. The more quill you have out of here, the less accurate the machine is, and at some point it'll actually stop feeding because it's run out of thread. You can slide this all the way out. So I have to feed this back in the opposite way to get the threads to catch right there. And now it's grabbing, and the threads are drawing it in and out of the tailstock. So know that that can happen too. You want to be somewhere in this mid-range in order to operate it. Find my chuck key driver, open this up, remember to pull this out, set it aside, and then I can check my fit here. And like I said, we are undersizing, so there's a fair amount of friction here. I think that's a good thing. We will still want to be able to turn our commutator. We will solder these wires on here coming up next, but we want to be able to turn that commutator, ooh, a little tight, in order to tune it or dial it in for timing of the electric motor. Other than that, a little bit of cleanup. If we get a significant amount of sawdust, we can sweep that up. We can take the bit out when everybody's done, but right now we'll leave it in for this singular operation. And I think that's it. Scene.